author has given the scale per se. So, and even if you do the content validity, it will only be a checking of the language against the previous one. That you do with the experts, with the language 2 people, which we said that at least there should be one person for back translation and one person for the forward translation. Okay. So coming to the exploratory factor analysis. So till now, what we have done, that you have seen that what activity we did. There was a empathy question, and in the initial first day, you people developed item. We have removed those reduplicated items. We have had a questionnaire which we have told you to fill up with the content, ambiguity, and clarity. And then we have given you a final version of the questionnaire, which was not the one which you people have selected, but that Toronto empathy scale. And you people got the data from various sources. We got that data. We performed the reliability analysis. Now, reliability was 0.8. So there is less of measurement error. So now what I had decided, what we people had, now we want to see, because till now we are considering that empathy as a broad construct, as a construct where all there are 20 like 17 items or 16 items. But I don't know about how in the psychological domain of the respondent who has filled this questionnaire, is it only a single dimension or there are more than one dimension? So to see the underlying structure of this data or of this scale or the psychological domain, I need to do the exploratory factor analysis. Now there's one more question. If already there is an established thing, if you read the, we have shared, I think, one article where using this Toronto empathy scale in Korean students, medical students, they have proposed this structure. So there might be that initial structure is unidimensional, but if you do it in your population, it might be more than one factor. Like GHQ, General Health Questionnaire. It was initially a unidimensional scale, but in Chinese population, in Korean, and in here also in India also, when we conducted study, the proposed structure is either a 2-factor or a 3-factor. It is not a single dimensional, or rather it is a multidimensional scale. So it depends. A scale which is by a unidimensional by some other population may be a multidimensional for you. That's why it is, again, many people will say whether you should do a EFA or not, if the scale is already like proposed structure is 2-factor or 3-factor. So it depends. As an author, you can just go and check whether it is the same structure which the literature is saying or your population is showing some other structure. We'll see these things in detail. So now coming to how do we process information? So starting from a child, when the child is small, how he processes the information. So if you see, a child get exposed to a lot of subjective and objective information. Every day, in everyday life, he sees something and he'll ask from parents, what is this? What is this? And you keep on telling the name of each of the articles or objective around that child. So if you see a child sees something, and after seeing something, he has got a mental mapping, and then he stores all these information in his brain as a construct. And if you ask that child to group all these articles into a separate group, he will have some background information how to group these. So how he will do? He will group these e-tables together. He will probably all these like conveyance things together, and that emojis as together. So how he's doing that? Some background information and some similarity between these two. So like he might club these together as a mode of transport, might club these two together as a facial expression, and might club these together as fruit, these as a probably the non-vegetarian source, and all these together as e-tables. But grouping of these objective thing is very easy. You can definitely, if you go somewhere, and we do this exercise in qualitative research workshop also, that there are ways to categorize or make clubbing, which we call it as a category. So if in case of objective thing, it is very easy for you people to club or categorize. But if the item is something like a psychological domain, when you are doing the mental map, when the person is answering something, so it is just reflecting the construct which is there in his or her domain. So grouping of these subjective item is a difficult task. Now, what can you see here in this diagram? Yes. So you can see there is a net and there are various color balls. So if I ask you to group these balls, how will you do that? So these brown and beige and red, maybe probably light blue and navy blue again, one category, and this black as a separate category. So again, what you see here in this picture, that there are various colored balls and we have grouped them together. So what is net, this mesh in this slide? What is this? Let me see your chart. Light color, EFA. Okay. CV. What is CV? Content validity. Okay. Demarcation line, network. So basically, if you see this mesh in this case is like a factor analysis. So when you do the factor analysis, basically that factor, it represents your placing of construct in your psychological domain. So, but again, it is easy to do this activity on color since it is very visible, but it is very difficult to do on the psychological thing. And there are mathematical tools to do that. And in case of scale validation, this net is called the factor analysis. So what is a factor analysis basically? So factor analysis, what we have done, we have, like in case of a empathy scale, we have got 16 items. So what we have assumed that how these items reflect underlying factor. Then there are multiple factors which can influence the variation in item response. In this case, if you see that it is not only the empathy, there can be other factor which can affect these items. And then we have to choose those items which precisely measure the latent factor. And to confirm whether the selected item accurately measure the intended factor, we need to do this factor analysis. And we assume that items in each scale reflect a single underlying factor. What do we mean by that? That means if there are 16 items in Toronto empathy questionnaire, we assume that each item is representing the underlying factor. That means there are 16 factors. So to understand that, let's see what is a hierarchical model around empathy as a construct. So what is a hierarchical model? If you see this social cognition, this empathy as a construct, so empathy, the broad construct of empathy is the social cognition. So it is the superordinate construct. Superordinate construct means a very broad construct. Under this social cognition, we have got several primary constructs. We call it as a primary construct, or you can call it as a first level construct. So the primary construct is like interpersonal skills, emotional intelligence, and the third is your empathy. So under this broad construct, you can see that there are interpersonal skills, there is emotional intelligence, and there is empathy. Now coming to the other secondary construct of these interpersonal skills, you can see the empathy, social perception, and the communication skills. So empathy is again like a secondary construct also, and it is acting like a primary construct also. This I am telling you from theory. No, this is again as a primary construct also, and this is as a secondary construct also. Now, empathy can also be defined as affective empathy, cognitive empathy, and behavioral empathy. So if you can see, it can again be subdivided into this again primary construct can be subdivided into a secondary construct. So this is known as the hierarchical model. What is a hierarchical model? Generally, there is a broad construct. We have discussed this on day 1 also. So generally, there is a broad construct, and then under that, there are primary construct, and then there are secondary construct. Or we can call it as a probably the main factor, and then associated factors with this. So if you see this, if you have understood this hierarchical model, so are you clear on this hierarchical model around any construct? Yes? Can I see the chat box? Yes. By factor, I mean to say dimension. Yes. Factors are dimension. In PCA, we call it as component, principal component. But yes, in EFA and CFA, that means exploratory factor analysis. Okay. Om Prakash is writing difficult to understand. Actually, this is very theory subjective. If you see, yes, quality of life is a hierarchical model. Quality of life is a broad construct. And then under that, there is a one question which is assessing the general quality of life. And there are questions which are assessing like various subcomponents. So quality of life like health. How we define health? Health is a state of physical, mental, social, spiritual, psychological, vocational. So many domains are there with the health. You cannot define initially, if you ask from students, generally they understand that health is only the physical health. If there is no illness, then I'm healthy. But no, if you see the WHO classical definition, although we say that is very idealistic and no one can achieve that, but you see there are various domains of health. So similarly, any construct, see, like if I want to know the public skills of public speaking, there are many people who are very phobic. If you have to go on stage and speak something, there are people who are very good at it, and there are people who will feel like nervous and anxiety and palpitation. We know quite a few people who take anti-anxiety drug and propranolol to go on stage, I mean, just before going to the stage. So what is that? That is, probably some type of anxiety, probably the, public speaking anxiety. But that public speaking anxiety, the person who has to take propranolol, maybe it is coming under a very broad this thing of anxiety. So overall effect, if you see the emotion, overall effect, you can classify it as a negative because it is a negative emotion. And then under that, there will be anxiety. In that, there will be like something known as the social anxiety. And under that social anxiety, this will come as a public, on a stage fear or public speaking anxiety. So any construct which we call, that is not like exist alone. It has got a hierarchy in that. It's a part of that. That's how, remember on day 1, we talked about the theoretical definition of construct, operational definition of construct. Can you recall that on day 1, which we did? While we make the scale, we have shared the video and PowerPoint presentation also. So if you read the previous day, it will be easy for you to understand the next day session because everything is linked. It is not in isolation. Like if you have understood today's session, then only you will be able to grasp tomorrow's session. Similarly, if you have understood well the day 1 and day 2, then today it will be easy for you to understand. So on day 1, we discussed regarding whenever you have to develop a skill. Generally, we talk these things when we have to develop a skill. If you have to develop a skill and if you are defining some construct, how will you define it? So you, in that expert committee, which I think Dr. Rupesh has asked, you need a person from a strong theoretical background also, who knows everything, all these psych, and probably the people from psychology, they have got the theoretical background of these constructs. So they help you in deciding this thing. We as a medical person don't decide. Did you get it, Dr. Om Prakash? I cannot decide. I have also taken it from literature because I have not read these, a broad construct and then again a small and then small. As a medical people, we were never taught these constructs, and psychiatry is not our domain. So even we don't know. But if I have to develop, I have to read it and I have to consult. And maybe in my team, there will be one person who has got a strong theoretical background. And he along with other people will define. So this developing this hierarchical model is the main important thing when we classified that you have to. I think you
अच्छा वो मैडम के पास है परा मैम अभी इससे पहले जब चेक किया वो
yes, so you have to when you do the operational definition and theoretical definition, so this will come under theoretical definition, and then you will operationalize this, means how you are going to measure affective empathy. So operationalization means you are going to measure how to measure this affective part of empathy, how to measure cognitive part, how to measure behavioral part, right? So all those questions which you see, they have all these components, that Toronto empathy. So have you understood? Dr. Om Prakash has written yes?
Yes, ma'am. Yes, ma'am.
Okay. Any other person?
Pardon?
Pardon, sir?
No. My question was like clearly like this hierarchical model, how we are going to proceed with. That's what I got confused with. So
okay, that's not our job. That the person who is there in your expert committee, he will, it's you will help him to draft all this. I mean, not help, you will request.
Okay.
Okay. So coming to the latent variable of this, you can see this here, you can see there are 16 items in the Toronto empathy questionnaire. So all these 4 sessions will be based, like 4-day session will be based on this scale also. Since this was the activity in the breakout room, you people collected the data. So all our examples are based on this only. Dr. Jalinder is asking, ma'am, doctor-patient relationship is an example of? Yes. Doctor-patient relationship, again, it will be an example of some social part. I think that will again, I'll tell you. That will again come under the social cognition. Under this social cognition, you can see there is an interpersonal skill. This one. So this one. This is just example I am giving you. This doctor-patient relationship will come under this interpersonal, because here also you will find empathy, social perception and communication skills. And under this interpersonal skills, you will define doctor-patient relationship is a type of interpersonal, because you can consider doctor as one person and patient as one person. And then you can define like it is one part of interpersonal skill where you have got these many. So you have to see, I'm just for example, I'm trying to explain. Then again, Dr. Saurabh is asking, all expert hierarchical model, all expert will suggest item of each construct. Generally in hierarchical model, it is done using the in-depth interview and focus group discussion. It is not like one person will suggest. You conduct many rounds of in-depth interview. If you can recall Ayushi's this thing, she has also suggested they have did I think from the students they conducted just to develop item. So they conducted, because for designing the questionnaire, then you have to take help of the expert. You will do the interview of experts also. You will do the focus group discussion of the experts. And then you will come out with the this thing. Or literature search, definitely. These people, you must have done the literature search. That's why you are planning to develop this skill. So based on the literature search, expert group committee, focus group discussion, in-depth interview, key informant interview, they will form an item pool. Pool means you might have an item of 100, 125. And then from that, you have to select a briefer version. Okay, for that you use the content, but that is there in the scale development. Okay. So if you have understood till this point, I'll go. So this is the latent variable empathy. Now I am introducing a new term here, which is the classical measurement theory. So this is the classical measurement theory. And here the factor which you can see, you consider this 1, 7, and then others are like also there. But since there was no space, so consider all these factor as 16 factor. Okay, 16 factor. And you can see the direction of arrow. So how should be the direction of arrow? If this is the empathy, then it will reflect all these 16 items. So what classical measurement theory says, that it takes that if there are 16 items, so there will be 16 factor. Means one item will be measuring one factor. That's the underlying assumption of classical measurement theory. So now, whenever we do the factor analysis, what is happening in the background? So taking this Toronto empathy questionnaire for factor analysis as a reference, suppose first is your initial exploration. So whenever you are attempting or the person is attempting something, it assumes that each item represents a unique factor. That means we start with 16 factor. That's what classical measurement theory says. Then, and this just with the example of child. So you can see a child here has got so many items, which we have seen in the initial slides. Then in step 2, by starting with 16 factors for 16 items, the factor analysis helps us to explore that whether each item measure up that particular factor or something else. Then it breaks into the various dimensions. So how it does? It clubs the items which are similar loading or which has got a loading. I should not be using this term loading because this will come later. So which are similar in characteristics. So as analysis progresses, you observe that 16 items, they cluster together. So in this case, you can see how the child was clustering. So we are just trying to give 2 examples together. How the child brain is processing and how this factor analysis is doing. So the way child brain has put these together, these mode of transport and these emojis or facial expression together, similarly, this what it does, that it make the 3 clusters into one factor, suggesting that it has got 3 dimensions. So it will make like clusters of items, suggesting the underlying dimensionality. So that is known as the dimensionality testing. And then it does the refinement. So again, at the last, it gives you the final structure. Those initial 16 items, it groups that into 3 or 4 factors based on how these items cluster together. So have you understood up till this point? Okay. So factor is this. Initial item is factor. I'll tell you. In case of a child, item is these apple, oranges, tomato, egg, fish. Each of these separate eatable is like a item. And when you group it together, it becomes a factor. Have you understood, Dr. Om Prakash and Dr. S.S. Roy? I will again repeat. But first see this simple one. These apple, orange, tomato, egg, fish, car, cycle, and these emojis. So how many items in this? Can you count? 1, 2, 3, 4, 5, 6, 7, 8, 9. So
Yes,
how many items?
9, ma'am.
9. So initially it will think it as a 9 factor. But again, when you club, like similar looking or similar function, whatever. So since these all are eatables, so it will club this together as one factor. Mode of transport as another, and facial expression or emoji as third factor. So clubbing of items is factor, and each of individual item is like an item.
Okay.
So factor is like clubbing of item. Have you understood?
So ultimately 4 factors are there, ma'am, in the image.
Here what happened, in one factor there are another 2. So there is sub factor. What you can see, that these are sub factor. This is factor and this is sub factor. But if you don't want to keep this, you can treat this as a whole as a one factor. This is just example. When you see the actual scale, it will become more clear. This we have just taken just to make things simple, so that you should understand what do you mean by moving these items or clustered together. Means they will be testing, or they can be clubbed based on some characteristics. So all these items together as a one factor. So, but Dr. Om Prakash is writing. So, Dr. S.S. Roy, have you understood this?
Yes, ma'am. Thank you, ma'am. Thank you.
Okay, my pleasure. And then, but the direction is the construct factor item. That is again something like construct is broad. So, if you can recall that hierarchical, so these, if you can recall this, these will be construct, and then there will be item measuring these construct. So here it is actually these factor which you can see here, they are items, 16 items, but we consider under classical measurement theory that each item is measuring the one underlying factor of that broad construct of empathy. So if we are done till that, and then it will give you a final structure which will reveal that instead of 16 factors, it might represent with 2 or 3 factors. So remember, those are items basically 1 to 16. But since classical measurement theory says that one item is measuring one construct. Construct means like primary, you can say like primary and secondary construct. It's not that broad construct of empathy. So that's why if you classify empathy, we have seen that empathy can be classified as the compassionate empathy, cognitive empathy, affective empathy, and emotional empathy. So maybe all these items which you are seeing, you will, if you see the factor structure, it might get broken into these 4 sort of factors that we'll see. So now the next question is, does a set of items measuring the different aspect of empathy reflect one underlying factor, like you were asking, or multiple distinct factors? So basically, you see that classical measurement theory says that there are number of factors is equal to the number of items, and then it clubs together. So the purpose of factor analysis, we identify the latent variable, and then we condense the information into fewer dimensions. So what it does, it condenses the items together, and then it makes the one factor, and then it keeps on doing till the variance is very less variance is left. So why there is a need to do the factor analysis? Why can't we stop at reliability? Yes? Question for you people. If we stop at reliability, what can be the problem? Or what are the...
items. There may be too many items, ma'am. If we know the factor, we can come down on number of items.
Okay, one is the performance of, but again, in the large set data also, you will come to know regarding the item which is poor performing. So you can remove that item and you can go ahead with the scale. Why to perform a EFA or maybe a CFA?
From reliability testing, we cannot have some the latent variable or this conglomeration of items.
Okay. So with yes, and there is one problem with the kappa statistics or the omega, this thing McDonald omega, that high alpha, if the alpha is if the questionnaire is like having a good length. On day 2, on Saturday, we did like, if you increase the number of items from 2 to 10, the reliability increases. And then again, with further increase, there is not much increase in the reliability. But if you increase the number of questionnaire, definitely the reliability increases. So if the Cronbach alpha is high, 0.8 or maybe 0.9, it does not guarantee that all items reflect the influence of a single latent variable, because it considered the scale as a unidimensional. What do you mean by unidimensional? Means all the items are getting affected by only single underlying latent factor or theoretical construct which we define on day one. So if you see the value, if the scale is of 25 item, even if there is a 0.14 item inter-item correlation is there between the factor, even then it will yield a alpha of 0.8. Whereas what inter-item correlation we have generally fixed, it should not be less than 0.3. But even 0.14 is a very less correlation. But if you increase the number of items, even with 0.14 correlation, it yields the 0.8 Cronbach alpha. So alpha is appropriate only for unidimensional set of item, and it can be misleading when we use multidimensional construct. So these are some limitations of alpha. Now that's why we do the factor analysis, because factor analysis, it tells you how many underlying factors are there in that construct. Because when you are developing a scale, or even if you are using a scale in your population, which you expect that they are different from the population where the scale was developed, then also you can test this if the contextual. Remember, we talked about contextual background of an item on Saturday, probably on day one, that there can be culture. Like if you use this scale in Canada, and if you use this scale in Bihar, in a population where the kids, they are being taught that you should be empathetic towards people, you should take care of the elderly, you should feel the pain of the people. So maybe by repeated saying or teaching, they will feel that, I should be empathetic. But that is not the empathy from within. That is something like a cultural characteristics which they have acquired. So in that case, it will not measure the true empathy. So that's why in your population, you should test the underlying structure. It might not be the same factor which the people of Canada will say, right? So that's why that broader construct is getting broken into how many latent factor that you should see. So it determines how many latent factors underlie a set of items, and it explains the variation among original items with the help of newly created factors, because you are condensing the information. And then you define the meaning of latent variable, because if 3-4 items make one latent variable, then you will define what is that latent variable. And then you identify the items that are poor performing or better performing. And then, like we said, that in the reliability, the question number 2 is constantly performing worse in the reliability as well as in EFA also, then you might take a decision to remove that particular item from that overall questionnaire. So now there is a conceptual summary of these factor analysis, how this factor analysis is different from what you have seen like in clubbing those items together. So this is one story, rather you can say example. It is there in the Robert, that book which we have shared with you. So there you can see that it is a group of people. So a new company wants to identify. I think somebody else can do it for me. It is just a simple reading. Who can read this for me? Anyone? Any volunteer?
Yes, madam, I am Saurabh. I am reading.
Yeah, thank you, Dr. Saurabh.
New company wants to identify what characteristics its employees believe are important for their co-workers to have.
Okay, so you can see there's a picture in this, and they want to identify that co-workers, means their colleague, what do they think? Because they work a lot on hiring people based on some characteristics. Okay. Yes, Dr. Saurabh? You can go ahead.
Yes, madam. The employees are asked to write on as many important characteristics as they can identify. They were given a paper slips to do so.
Okay, so they were just like the paper to write their characteristics. So what the HR manager did, he taped each paper slip on a big board. Like someone has written willing to share ideas. Someone has written thinks, the person who thinks logically. The person who has got a team player trait. The person should be having a good sense of humor. These were given by individual people. One person might have given 1, 2 or 3 chits also. So good sense of humor, reliable, hard worker, intelligent, storyteller, well-educated, trustworthy, and isn't sloppy. So maybe these were the chits what people have written, and the HR manager has clipped all these papers on a big board. Now the HR manager asks their employee to see if any characteristics that they think that they should go together, like grouping of something, because ultimately they have to give a name of that broader construct. So employee clubbed the characteristics like this. So they have clubbed like willing to share ideas, logical thinking, sense of humor as one, pay attention to details as one, team player means he's reliable and he's a hardware worker also. So all these three together, and person who has got a good sense of humor can be a good storyteller also, and for good sense of humor that person should be intelligent. So they have grouped these items together. These as one group and this 4 as a one group. So the HR manager asked the employee to give a name to these 3 traits which you have seen here. And they have given 3 names, like intelligence to this one. So this group as intelligence, this group as a conscientiousness, and this group as a dependability. So they have given name to these 3 clubbing of the traits together. Okay. So again, you can say that these were the individual item which they have generated, and together clubbing of these, you can call it as a factor. Okay. Now what happened? Several years later, the company decides to repeat the exercise again. But the HR manager is a different, the earlier one, he has resigned. So the HR manager is a changed person. So now so first tell me, what was the problem with this exercise? This one. Yes?
Yes, subjective.
First is subjective. Again, in this case, there can be one person who is not very who may be not able to think at that particular time point of some words or some phrase, or who could not participate in clubbing also. He will be like left, and his idea or his thought process will not be accounted for here. And the person who is very knowledgeable, means having a lot of words and who are very vocal, who are like, all the time outgoing, they will be more appropriate. Yes, Dr. Sheetal, it is like a free listing and pile sorting. You are right. So this you can see here, that a person who doesn't speak too much or who doesn't write too much, probably he will not participate. And again, in this case, there can be one person who has given name of 4 or 5 traits, and there can be one person who has not given name of any trait. So to include everyone, what the new manager has done, he has just developed a questionnaire. So using that particular traits, he has developed items and statements, and then he has asked regarding to rate from each of the employee, to rate on that particular trait, that how they feel that this trait is important for their co-workers to have. So he has just clubbed this, like this trait is not important at all, somewhat important, and very important. So he has clubbed it in 3 parts. So this new HR manager took the responses, and then what he has noticed, like different characteristics were important to different employees. That's true, which happened in the first exercise. But there are certain characteristics which everyone, like they rated that this should be definitely there, this should be definitely there. So there were some characteristics which tended to be similarly rated by everyone in that particular group. So what that HR manager did, he not only did the grouping of those content, but he has also shown that what are the common traits which all the employee, they said that those things are important in their co-worker. So now, for example, previous HR manager has just grouped like things logically. Now new HR manager has given this question is like things logically, this trait, how important this trait is for you? Not at all important, somewhat important, or very important. Here also you can see not at all, somewhat, or very important. So a male might say that it is somewhat important. A female might like put it as very important. Logical thinking, team play, very important. So something like that. So you can find viewpoint of each and every one on all the trait. So that was the difference. You can think the difference between these are some of the questions which are on there, although it is there in the 3-point Likert, but this is on a Likert scale. So we have discussed the shortcomings of the first method and the improvement in the second method. So now coming to the extraction of the factors, how the factors are extracted. So initially you start all the items in one construct. So that's what we thought, that all the items are there in one factor. Sorry. And then you see on the basis of variance. So remember, we have talked about variance. It is basically the difference from the mean and then square it. That is the variance. In case of scale, how you do define the variance basically? So that variance is, all these are depending on how the items are co-varying, means how they are getting affected by the underlying construct. So you just see like how much variation in the item is explained by latent factor, because in this case, as we have seen, that the item is the dependent variable and latent factor is the independent variable. Similarly, factor 2 will be decided like how much of the variation of the item was explained by another factor, and similarly factor 3 and factor 4 will be extracted depending on it, till in the last there should be very small variation which should be left in variation in those items. Basically, we are talking about variation in item. So again, depending on that, at the end, it stops making new factors till the time very small variation is left. Like you can see here, this is again the same reflective model. So this one, the factor 1, some X amount of variation in A to I is explained by factor, and next of the variation was explained by factor 2. So it is only saying that a change in item is not only reflected by one factor. There might be some other factor also. Like you have seen in the empathy, there is a cognitive empathy, there is a social empathy, there is an emotional empathy, all those types of empathy. So if you just take one item, you might not find that, that only one factor as a broad empathy is there. Rather, there are other smaller factor of empathy. So in the course of scale development, we often want to know regarding which are the most influential source of variation in the underlying set of items. Because if you have taken 16 items, what are the underlying latent factor which are responsible for the maximum number of variance? Because you cannot take all the 16 factor into account. Then it will not be a dimension reduction process. So factor analysis, basically it is of two types. There is an exploratory factor analysis and there is a confirmatory factor analysis. So exploratory factor analysis is used when you don't have a predetermined structure. But even if it is a predetermined structure and you think that your population is different from the initial, like from where it is developed or tested, you can test this in your own setting also to see how your population data is showing the structure. And then using that structure, you define a model and you do a confirmatory factor analysis. But there is one catch in this. You should never do a confirmatory, exploratory factor analysis and a confirmatory factor analysis on same sample. That means like we have got like 360 total responses. So what we did, initial 200 we used for the factor structure, and next we used 160 we used for the confirmatory factor. You should not do like you take the data of 200, you do the EFA in that, and you do CFA also in that. That's why if you want to do both, you have to take large sample. Large sample means how large it should be? 10 to 15 per variable for exploratory, and 5 to 10 per variable means per item for confirmatory factor analysis. And when do we do confirmatory factor analysis? So it is used when we have a clear hypothesis or theory about the structure of our data, right? So if the predefined structure is already there and you don't expect that your population will be different from the previous population from where it is tested, then you don't need to do exploratory. You can directly go to a confirmatory factor analysis. Okay, so Dr. Om Prakash is asking why so. Regarding which, Dr. Om Prakash, you are asking why so?
So why to use two separate samples for like exploratory and confirmatory factor analysis?
Because in one sample, you are developing the factor, you are developing the model, and the other, you are testing that model. So you cannot do both the thing, because that population, if it has given you the structure, you cannot test it. It will be like rather for testing, definitely you should have another population. Because if you use this, like
I don't tell you that I have already tested exploratory factor analysis with that, and I give it the same model for you for confirmatory factor analysis. So how it's going to be different?
no, on the same sample you are saying.
Yeah.
So it will be a misnomer. It will not, model will always come fit if you do it on the same sample.
Okay. So we are going to fit it with the exploratory with the confirmatory.
Pardon?
No, what we are going to test using the exploratory factor analysis, we'll be using to see the fit with the confirmatory with the other sample. Am I right, ma'am?
Yeah.
Okay, now I got it.
Okay. Okay, yes, Dr. Venkatesh is writing like using same question paper for model exam and for final exam. Yes, true. Dr. Shamshad was also giving the same example, that what you have asked as a pre-professional, you've asked the same question in the professional, or probably the same thing. Means that it should be different, because then it will not be a testing, since you have developed the factor structure from the same data. So if you put the same over the model, it will show you a very good model fit, which is not the case, because it is the same sample. So Dr. Latika is 10 to 15. Yes, Dr. Latika, take higher one. So consider 15 in EFA and 10, because otherwise you won't get model fit measure very good. So why I'm saying this, we were analyzing the data, I think yesterday morning at 10 o'clock, what responses we received. So at that time, the CFA, when we performed CFA, all the model fit measure was very horrific. Like it was not fitting at all. So we thought, I'm just sharing the experience with the data which we received. So me and Dr. Shamshad were sitting and we were analyzing the data yesterday morning. So the model fit measure was not that good. But at night till 9, many data again, data was it were coming. So then when we analyzed today, the model fit measures improved. So that's why there is an importance of sample size. If you take less sample, your model fit measure will not be good. So you should you can take more than required also. There's no problem. More than required, generally we say like 400-500. And there's one more catch in this. Regarding sample size, what you should do, you test your model in, let's say, 150, or means like even if you want to take 5 per variable, you test this in, let's say, if I talk about the Toronto TS, then you test in 80 sample. If it is not fitting, then you double the sample. You take it in 160 and then do it. And then again, you see that your model will improve. So even if at less sample size, but generally that doesn't happen, that at lesser sample size, it shows the model fit. So at least you should go towards the higher one. If I say 5 to 10, take 10. If I say 10 to 15, take 15. Then you don't need to do so many maneuvering to make your model fit measure good. Otherwise, you have to do a lot of statistical manipulation to make that model good fit, which should not be there. Otherwise, it will not be like very much replicable to other setting.
Ma'am, one more doubt, like EFA we are doing suppose on 200, but if still like it's not giving a good result, and so
I'll
will
tell
it affect my sample size as well? Like in the study, I will be this is pilot testing, right? So if
It's not pilot. We have got 360 data. So now it is not a pilot. You cannot do EFA on 50. 50 you only did in the pilot testing the reliability. Then you have given the questionnaire to the
right,
larger sample.
okay,
And then once you are there with your actual data, 200,
Right.
250, 300, whatever, then you can decide to do the factor half-half. Many people, they do half-half. Like they have got 400 sample, initial 200, they check their factor structure, and next 200, they check for their confirmation of that factor, which they have yielded in the exploratory factor analysis. And there are ways to get a clear factor in exploratory factor analysis, which we will discuss when I'll show you over JASP and JAMOVI. Like there are few tricks on the basis of that you can have a clear factor structure. It's not trick, rather it's there, means it's a statistical procedure, you can say.
And so we have to do both the exploratory as well as confirmatory on the full sample size. Like we have to follow both of these. Or
Again, to say this, what I will say, see, like if you can't take, it is not possible for everyone. Like if you are doing some small project or some thesis, and its duration is limited, because you cannot have like 2-3 year. Data collection process is generally for 1.5 year, maximum 2 year. And if you can't, and if it is not a self-administered, because seeing the literacy of the people, if you are going to take the interview, or even if it is self-administered, you are going to a particular setting and taking the interview. If that many data collection process is not possible, and the initial, and you think that if it has been tested, because you are doing the literature review also. Like like I said that in Korea, we have we shared the paper? We have shared the paper. You go and read that paper. They have given us that factor structure. I have got a theoretical this thing of that factor structure. So what I can do, like I can, if I just don't want my sample size, that I don't want to take 400 sample because I have that much, I don't have that much time. So what I do, I can directly go for CFA, because since I will say that since the factor structure is known, so I will go for CFA. I will not do the EFA, because I have not modified the questionnaire. I have used it because they have done it in the medical students. So if I am doing here at AIIMS Patna, maybe I can take a decision not to modify it, use it as such, and use that factor structure which they have proposed, if I don't want to increase the sample size. But if I say no, I want to test it in my population, I don't know how the factor structure is here at AIIMS Patna. So then what will I do?
half pay,
I will
EFA
increase
and
the
half.
sample size.
Thank you, ma'am.
Okay, did you get it?
Yes, ma'am. Got it clear. Thank you.
So should we go ahead? Any other question? No. Okay. So this was the confirmatory factors. Now, there are some underlying assumptions of exploratory factor analysis. Like we are testing multiple variable on a continuous scale. So one thing is, like, you cannot do exploratory or confirmatory factor analysis, or even the reliability analysis, Cronbach and McDonald, on two binary response. Remember, we discussed the type of responses: binary scale, Likert scale, semantic differentiation, rating scales. So for Likert scale or for even for rating scale, wherever the responses are 5 or more than 5, because we consider Likert scale having 5 responses or more than 5 as a continuous variable. So that we'll treat it as a continuous scale. There should be linear relationship between the variables. So by correlation or by scatter plot, you can see this. But if the reliability has shown that there is a correlation, then you will see that this assumption is met. And there should not be significant number of outliers, although you will see that there will, in case of a Likert scale, you may find some outliers, but it should not be too many. And again, if you have got a large sample size, although we have written 5 to 10, but you remember 10 to 15. And then the next assumption is the sphericity and sample adequacy. We'll discuss this. The objective criteria is the sphericity and sample adequacy. That we'll see. So the first assumption of factor analysis is the concept of multi-collinearity. Now, coming to, if you can recall linear regression, those of you who have attended or maybe who have a theoretical background or some exposure of linear regression, we have learned this concept there also, multi-collinearity. What is a multi-collinearity? Can someone say before we go ahead? As the name suggests, multi-collinearity. What is multi-collinearity? Anyone?
And the variables are related to each other. The variables that we are studying, they have some kind of relation to each other and they are very similar.
Yes, very right. Especially we are talking of the independent variable. Independent variable in linear regression, which are right towards the equal to sign. So they are related and they are, generally we talk multi-collinearity, that if you increase one, the other will also increase. So there should not be too much of multi-collinearity in linear regression, because then that affects model. In that case, you remove those variable, and we, if you can recall, we check this with the VIF. There is a VIF, variance inflation factor, by which you can detect this multi-collinearity. That was there in the linear regression. Here also, all these items, what are these items basically? We have learned that what is reliability? Reliability is like there is a correlation between all these items, because you cannot measure the construct. So if the items are correlated, you will assume that all items are measuring the underlying construct. That's the assumption of reliability, that all these items are measuring. That's why you see the correlation. So in the case of factor analysis, what you want? You want factor to be correlated, or you don't want the factor to be correlated? What do you want? Factor means maybe items. All like correlated. Of course. Why? Because if they are measuring the same construct empathy, if all 16 items are not correlated, then they will not be measuring the underlying construct. True. Yes, all of you are right. So what is the null hypothesis in this case? The null hypothesis. Okay. So before that, there are some pictures for you. Like you can see, if you see these items, can you figure out a common place through which all these items are related?
Kitchen.
Kitchen. Yes, right. So in the same analog, when you use many items to measure a construct, they can tell you that these items are correlated to each other with certain degree. So this existence of these correlations are known as the multicollinearity. So the null hypothesis that assumes, if you see this, the null hypothesis assumes that the multicollinearity among all these items does not exist. Okay. So what do you want? You want, and there is a Bartlett's test of sphericity, which tests this multicollinearity, means it says that there is correlation among items. So null hypothesis states that there is no multicollinearity. So what should be the p-value if you want to do the factor analysis? Because if the factors are not correlated to each other, you cannot do the factor analysis. You say that the data is unfit for factor analysis and you cannot proceed. So factor analysis to be like effective, what should be the value of P in case of this Bartlett's test of sphericity? More than 0.05? More than 0.05 means you will be accepting the null hypothesis. So you want that multicollinearity not to be there?
No, we want collinearity.
Yes.
We don't
Then
want
you
null
have to-
hypothesis.
So then you have to reject the null hypothesis. Then only, because if null hypothesis says that there is no collinearity, then you have to reject this. So it should be less than 0.05. Yes. We don't want more than that, because more than that means you are accepting null hypothesis. Now coming to the second assumption, which is the sampling adequacy. So what is a sampling adequacy? There is a KMO test. We call it as a Kaiser-Meyer-Olkin measure, KMO measure. So what does this KMO measure test? If the value of this KMO measure, generally what it does, it checks for the sample adequacy. I'm not going to the underlying theory of KMO because then it will complicate things. So just remember, if the KMO value, if it is more than 0.6, that means you can go ahead with the factor analysis. Threshold is good is more than 0.8, but acceptable is more than 0.6. So purpose is it basically evaluates the common variance among all those items for the factor analysis. So if you see the ranges, 0.9 to 1 is excellent. 0.8, more than 0.8 is good. But you should remember, it should be at least 0.6, more than 0.6. If it is less than that, then you cannot do the less than that is unsuitable for factor analysis. You cannot do factor analysis. So if I go ahead, and third is the assumption 3 is for the number of factors to be retained. How many factors do you want to keep? So that is decided on 2 to 3 criteria. I'm just telling you the theory. I'll show all these. Once again, we'll see this when I'll show you on the data which we have received. So how to decide how many factors should be there? So the first criteria is the eigenvalue. Eigenvalue is the most common criteria. What is eigenvalue? Basically, eigenvalue tells you the amount of variance which is explained by the each factor in factor analysis. And what is generally we take the value of more than one eigenvalue. So the factor which is giving you more than one eigenvalue, we typically retain those factors. So purpose is basically if you want that all the factors which are there in your factor structure, they should be meaningful. You can use eigenvalue to take a decision on the number of factors. The second criteria is parallel analysis. So we recommend parallel analysis because that's more robust and that's the latest recommendation by the all researcher that you should do the parallel analysis. Now, what do you mean by parallel analysis? So parallel analysis is basically like let's say, it is a method which we use to determine the number of factor structure in a factor analysis. And this particular is determined by the number of random number data. So how this random number data will be generated? So what do you do? Like let's say I am performing this EFA on 200 samples. So what it does, it first takes the initial factor structure on 200 sample. Then it generates many random data, means data of, let's say if it is 200, by mistake I was saying random number, it was not random number, rather random data. Means it might generate from 200 random data of 60, random data of 80, 180, and it makes so many iterations and it takes out factor structure in all those real-time data, and then it compares the average factor structure of that random data from this data which you have derived. So decision is that your factors which you have driven through in the initial structure, the eigenvalue of your factor structure should be more than the eigenvalue of that randomly generated data. So what happens? Like it is just telling you the steps. So in step, it generates the random data matrix with the same dimensions as actual data. Then it performs the factor analysis on both actual data and random data. Here, if you see this, it performs. And then it compares the eigenvalue of the actual data, those derived from the random data. And then you should retain only those factors whose eigenvalue are larger than the actual data. Like, we'll see that in the diagram. And the third is your fixed factor. Fixed factor is you, from a prior research, you know that there will be 3 factors and you enter those many factors in the data analysis. So that is dependent on the theoretical construct which you have decided. And fourth is the assumption of scree plot. So what is a scree plot? Scree plot is a plot between the factor and the eigenvalue. So if you see this, it is a visual tool to determine how many number of factors you should retain. And you should look for the elbow or point where the slope flattens. I'll show you. These things you will not understand, yes. So see, this is a scree plot. Scree plot is a graph between the factor. You can see here. It is the graph between factor and this is the eigenvalue. Okay. So you see that you have decided for the more than 1. If the eigenvalue is more than 1, you will take that factor. And elbow, but many times it is difficult to decide what is the elbow. Now coming to this, how will you decide on this? This is creating confusion. Whether you should have 3, 4 factor or a 5 factor. What do you say? This is the 1. This is the 1. So if you take more than 1, then it will be 4. But if you include 1, then it will be 5. So here it is clear, but many times it doesn't show you that clear-cut elbow. So there is a problem with scree plot also. And this is a scree plot of, this is the graph which we have performed on the data which we received from you people. We will show you. So this is a scree plot of TQ-EFA with parallel analysis. So what is this in the background? Can someone say? You can see what is this? These letter I should.
The random random analysis, data analysis, where it shows above that, where we can take it, consider
Yes.
that.
So this line, if I see, let me draw one line. Yeah. This line, this is your parallel line, means line of parallel analysis. Yeah, I'm explaining once again. And this is your, this what you can see here, that is based on your, that is the scree plot. So how do you take basically? It should be above this line, which Dr. I think Srinivasan was saying. So how many factor we'll take? 1, 2
3.
and 3. If you use this eigenvalue, how many factor you will take? How many factor? If more than 1 eigenvalue?
4.
4. So it is up to you. Now in analysis, you can take any criteria. I'm explaining, Dr. Nitin. Criteria 3 you are saying. So criteria 3 means scree plot. No. Fixed factor.
Fixed.
Okay. So fixed factor is like, while developing the operational and theoretical construct, if I have divided empathy into 3 parts, emotional empathy, social empathy, and cognitive empathy. So I'm sure that I will get factor based on these 3 theoretical construct. So I will, since beginning, I'll put it 3 factor. Okay. Or If I don't want a huge structure, and I'll say that I will only accept less factor structure, then also I can go for a fixed factor but it should have some theoretical background, because when you commit this in the analysis, then you have to justify why you have used a particular method of extraction. You have to justify why you have used fixed factor, why you have used eigenvalue, or why have used parallel analysis. So you have to explain that in your analysis. So generally, fixed factor can, if you say that you think, I mean, from theoretical construct, you have decided that your broad construct will be broken into 3 factors. So you have decided to go for fixed factors. Am I making myself clear, Dr. Nitin?
Understood.
Thank you. So have you understood up till this point? So these 3 methods we have discussed regarding the number of extraction, number of factors to be extracted. Fixed factor or it can be based on Scree plot, it can be based on the eigenvalue, or it can be based on the parallel analysis. All those 4 options are there in the JASP and Jamovi both. And you have understood the concept of parallel? When the calculated random data, so your eigenvalue of your factor structure should be more than the random data generated eigenvalue. So that's why you will, and this is what generally we recommend. And you can see here, this is the data point and this is the simulated data from the parallel analysis. These are the 2, here you can see the dot and the triangle.
No, I have a doubt.
Yes, please, Dr. Om Prakash.
Why this parallel analysis looks very straight? I mean, like,
because they take the random the simulated analysis from the random data from more than 25 or maybe many sets of data, and they average it. So that's why it looks such like a straight line. And ours is only based on single set of data.
and if I'm not wrong, what I understood was like the parallel analysis will be, each factor will be analyzed with the parallel random data and the original data. Am I right, ma'am?
See, initially,
Eigenvalue will be compared for each factor separately with the random data.
actually, you should not call it as a factor. Means there are, initially you have thought that there are 16 factors, but you see the set of factor, initial few factors where the items are there, those factors, how much variance it is explaining. So basically it takes account of the variance.
Okay.
How much variance in the scale item that latent factor is showing. So that's why you can see here, later we will see in the analysis that initial 3 or 4 factor structure, they explain 60% of the variance. Then even if you add factors, it is only going to add 1 or 2% of variance, and which will complicate the whole data structure, means the factor structure. So that's why the dimensionality reduction which we talk, that will not be possible.
So that's what all about the eigenvalue is. We
Yes.
talk more about the variation, the latent variations.
Yeah. How
Okay.
much that factor structure is explaining means how much that latent variable is explaining or affecting that change in that factor after having all these items.
Okay.
We will see that in the analysis.
Okay.
These one by one. We'll go very slow. These are again the same thing. So how many factor you will extract from this? This is again from the parallel, and this is the data.
25 factors.
So 3 and 2, 5 factors, because after that it has gone down. Yes, you are right. So now there's another concept of uniqueness and communality. So what is uniqueness and what is communality? So these are again, you can say that side of the same coin. Uniqueness is the proportion of variance that is unique to the item which is not explained by the latent variable. Remember, there is a term error which we have seen in the reflective model with each of the item. Can you recall that picture? Probably it is not here. That E and all. If you see that. No, it will not show.
At xi only, factor.
Let me show you. So that E1 and E2, yes, I'll show you over that. And what is communality? Basic communality is the opposite of uniqueness. So if the uniqueness error is 40%, your communality will be 60%. Communality is what, like shared variances. How much variance in that item can be explained by the latent factor. So if you see this communality versus uniqueness, yes, Dr. Saurabh, you are right. We'll see right now. I think I have pasted that equation. No, probably that is not, that doesn't. No, I saved that slide probably. Okay, that's okay. So communality is like amount of variance an item can be explained by the latent variable or construct. And uniqueness is the error term, which is the left, which is not explained by the latent variable or the construct. So if you take that, and there are two types, if you see this, there are two types of variances. One is shared variances and one is unique variances. So shared variance will be this much. Shared variance is known as the communality and unique variance is known as the error. So Jamovi and JASP gives the error part, means it gives you the uniqueness. Whereas if you see this SPSS, it gives you the result as a communality. So for example, if communality of an item is 0.72, then you can say that the unique error associated with it will be 0.28. That means if I have to explain, I can say that 72% of the variance in an item is due to the latent variable and rest 28% is due to the unique item. So I'll just show with one example. Okay, I'll stop sharing this and I'll show you with one example. So can you see this screen? So if I explain like this is the everyone. Okay. I1 is like lambda 1 factor 1 plus lambda 2 factor 2. This was like if we say two factor structure. If there are two factor 1 and factor 2, and it has got like I1 and I2. Two items, there are four items. I1, I2, I3, and I4. So these are the items of factor 1 and these are the items of, these are the main loading, but there is a cross loading also. So I2 is again lambda 1, lambda 2, F1 plus again you can write like 1, 1 and 2, 1. And this is your 2, 1 and 2, 2 and F2. So what is communality? Basically these lambda square. If you square this lambda 1, 1 square plus lambda 2, 1 square, this will tell you the communality. For I1. So communality is there for item. And if you see the eigenvalue is there for the factor. So eigenvalue is there for the factor and communality is there for the item, means a particular item. So for communality, what you have to do, this lambda is the loading. We call this lambda as loading. And when you square the loading of each factor and add it, it gives you the communality. And if you deduct this from 1, it gives you error. So we will do this when we have an output. So now I'll go with this shared part and the uniqueness. So now factor analysis tells us whether the item selection process was successful or not. So this we have done about the method of extraction. Now coming to this, we know that what reflective and all. So yes, this is the cutoff of the factor analysis. The Kaiser-Meyer-Olkin value should be more than 0.8. That we have done. But acceptable is, even if it is 0.6, that is acceptable. The total variance explained by the factors should be more than 60%. That we'll see. The communality means the uniqueness. You have seen the shared variances. It should be more than 0.4. We have not discussed this rotating factor loading. We'll discuss that. But factor loading or lambda, which we have seen, that should be at least 0.45. But better is that it should be 0.5. And the Cronbach alpha should be at least more than 0.8. But even if it is 0.7, it is acceptable. So you should remember these 3 criteria because you have to write the interpretation. So this we have done. Now coming to the concept of factor rotation. Till now, we have done what? Method of factor extraction. So there are 4 methods of factor extraction: eigenvalue, parallel analysis, then there is a concept of fixed factor, and then there was one more. 3 factor, yes. Scree plot. Yeah, thank you. Scree plot. So there are 4 ways of the factor extraction. Now, if you see the factor extraction, that clear-cut structure is not visible if you don't have rotation. So this you can see by this example. So just imagine we have tried to show this concept of rotation using a subjective way and using an objective way. So imagine yourself in a room where there are bulbs of multiple color hanging from the ceiling. Can you see there is a ceiling and there are multiple color bulbs? If you imagine me or wherever you are sitting, imagine yourself and there are multiple color bulbs which are hanging from the ceiling. And you are this person which is moving from, yes, who is there? So, which is moving from one place to another place. So this person is moving. Now you have changed your position from P1 to P2. So you have moved from this place to this place. And then you take out the sum of distance from your earlier place. So from here, you can take out the distance and add it. Now you have moved in this position P2 and you take a sum of all these and then again you move to this position which is the P3 and then you take the distance of all 3. So what is rotation? In a room, in a 3-dimensional room, you think that you are standing in a position. It is there in the psychological domain. So from a position where the distance of these bulb is the minimum, you rotate the structure like this. Means not you rotate, means statistically it is rotated. There are ways of these rotations. So it is rotated in such a way that distance of all the bulbs in this case should be minimum from this person. So this, if you can imagine in a 3-dimensional space where the sum of all distance will be the least, then in this case, where will be the sum of all distance will be the least? This is the P1, this is the P2, and this is the P3. So there will be a position. I'm not interested in which position, but likewise P1, P2, and P3, there will be one position where the sum of distances are least. And this is known as the rotation. Means you rotate the 3-dimensional structure to such an angle where the distance of those multiple factors from the construct should be minimal. But what happens if you restrict the movement in a room space? So there are 2 ways of rotation. There's an orthogonal way and there is an oblique way. We'll see that. In orthogonal, you fix the distance between the two, the angle between the two, this latent factor on 90 degree. So if you fix that, there will be limitation in movement. In a room, if you fix that, you have to only travel through walls because walls are along 90 degree. So if you can only travel through wall, what will happen? Your movement will be restricted. If you can walk anywhere in the room, you will be free. So the best, we will see that oblique rotation is considered the best if you are doing a scale development and factor analysis in case of a health. So finally, we got this point and we tried to look and make some pattern from a distance. So you can make pattern like this, all like red color or all that purple or violet color, all bluish shade. And these you call these bulbs, you can think of individual item, and this is regarding the factor. So from basically rotation gives you a clear-cut structure where it is very much clearly visible that these particular items are loading on one factor, the other two on one factor, and the rest on the third factor. But sometimes you may not find any pattern at all, whatever position you are there. So now, if you replace the room space with the psychological space, and if you replace the individual with construct, then if you replace the bulb with items, then you can understand the concept of rotation. So the pattern which, the different color pattern which you have seen, that will be called as a factor or dimension or component. You can use these three words interchangeably. Have you understood this? Then I'll go with the graph. Have you understood the concept of bulb? Bulb were the individual item. The person which you have seen, the individual, that was the construct. And the clubbing which was there, it was the factor or component or dimension. Let me see the chat. So chat is saying only 1% Dr. Samina has written yes. Do you want me to repeat? Okay, Dr. Saurabh is writing yes. So I was just trying to tell you regarding the concept of rotation. So rotation is basically, what do we do in rotation? Sometimes you see, have you seen that anytime with a pipe hole or with the, how should I explain? Maybe you change your angle to see something very clearly. If you are seeing someone from front, and if you just change your angle to see that person from side, you may have some other look of that person. So yes, I'm repeating, Dr. Muhammad, I'm repeating. So this is just to tell you that imagine yourself in a room. Okay, you are in a room, so you are a construct. And there are various color bulbs which are hanging from the ceiling. Okay, so what is happening? You are changing your position. So first you are standing here at P1. So you have measured the distance. It's you as a construct and the various colored bulbs are the items. So you are measuring the distance, this distance, if I see. So you are measuring this distance, this distance, this distance, this distance. There will be distance. Distance is like distance of item from the construct. These are the distance. And then you average this. So you will have got some position. If you move your position to this place, now you have come up here. Again, there will be individual distance from each of these items. This one, this, 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 likewise with all. Again, you take the sum of all these distances. Now you have moved to position 3. Again, there will be some distances like this, this. So now that's how there will be a position in this room. Room is your psychological space, and this person is the construct. So basically, there will be position in our psychological domain from where the distance of all these items will be minimal. Minimal, what do you mean by minimal? Means they will be as close. These distances are called as error. Okay. So if the error is minimal, what will you conclude? That you are measuring, the items are measuring the latent construct as closely as possible. Can you say that? Please say yes or no. Then I'll again try to explain it with some other way. Distance are error. So if the error are more, if the distance of the items from the construct are more, that means the error is more. If the error is more, that means your construct which you are measuring, that is not the true measurement of the construct. So rotation gives you the value of the position from where you can have the minimal error, and from that position, if you see and club means your psychological domain, club these items together, that is known as the factor. So these factors are made from a place of latent construct where the distance between the latent construct and the items are minimal. Means errors are minimal. Have you understood up till this point? Yes. Dr. Muhammad, have you understood? Okay, thank you. Now coming to another.
Yes, ma'am.
Okay, thank you. Yes, now let's understand this with actual 2D graph. So here, what can you see? This is your psychological domain. Okay, this brain, or you can see this inside of brain. This is your psychological domain. And these are 6 factors. X1, X5, X4, X3, X2, X6. They are placed like this. Okay. And there is, you can say, so this is the unrotated structure. These methods, we are just trying to see the rotation. So this is unrotated structure. This is factor 1 and this is factor 2. Okay. This is not rotated. These 3 are together and these 3 are together. Now consider the distance of each item from axis, because we have discussed that this is error. So if you calculate the distance of these factors, both from, there are two, it is a 2-factor structure. So this is for the axis of factor 1 and this is for factor 2. So you calculate the distance of these two from the axis. So this will be the distance x, like the x and the y component. For x3 item, this will be your y component and this will be your x component. Okay, this is your unrotated structure. Now, if you rotate this structure like this, but you have rotated it in 90 degree. Again, you can see the angle between these two is 90 degree. So you have rotated the factor structure, factor 1, 2 from where the angle is again between these two is 90 degree. And then you consider the distance. So again, there will be some distance. So you can measure the distance between this. These are variances or error. And then if you allow the factors to rotate at any other angle rather than at 90 degree. 90 degree means orthogonal rotation and oblique means not orthogonal, means less than 90 degree. So if you allow this to have an angle less than 90 degree, then you can see the distance is minimal from this axis. If you calculate these distance, if you add it, you will find that these are the minimal. So that's why in psychological space, the distance between the construct item, the factor item, and factor, this all is measured as a correlation coefficient. So like this example is given in Robert. If you see these pipes, this is without rotation. So you can't see a clear structure. But if you rotate this, now can you see that there is a clear structure? These all are together, then second, and then third, and then fourth. So this is
Yes.
an orderly arrangement of pillars viewed from perspective that reveals orderliness. And if you don't see, if you see from without rotation, unrotated, then it will not give you any clear structure of factors. So that's how the importance of rotation. That's why in factor analysis, you do the rotation. Okay. There are two types of rotation. If the angle between the factor is 90 degree, it is called as the orthogonal rotation. If the angle between the factors is less than 90, it is known as the oblique rotation. Have you understood up till this point? Priyanka is writing yes. No other person? Okay, yes, thank you. Means you only understand that through rotation method, you can see the factors loading very clearly, and it helps you to give a factor structure. So two methods we have just learned, method of extraction and method of rotation. Extraction, number of factors, how many factors you will have, and rotation gives you a clear-cut loading of the factors. We'll see. So this was the Toronto empathy questionnaire. Now I will show you in Jamovie and JASP how to do that. And then we'll see the reporting. Reporting, how to write the result, that we might see tomorrow, as there is not that much time is not left. So if I go to data, this file has been shared to you. So first I will show you with the, let's see with the JASP. I'll show with the Jamovie also. So we have done it on 200 sample. So I'll move these items back. So if you open this, you can see there is a window of exploratory factor. These are the variables. So first I will move all the variables here in the, this is one. And then item 16. There are 16 items. And in this case, there is no need to do the reverse coding and all, because it gives you the factor loading. So there's no need that you will reverse code the structure. Now, first focus on method of extraction. Can you see this? Please focus on left side. You can see there are options, number of factors based on parallel analysis, based on eigenvalue. This is the eigenvalue. And this is your manual, means number of fixed factors which we were discussing. Okay. Now there was another thing which I did not discuss, factoring method. So there are various ways of factoring method. You can see that here there is a minimal residual, maximum likelihood, principal axis factoring, and ordinary least square. So best is your principal axis factoring. This should be there in the choice, because that is the most, it will give you the most favorable factor structure. So select principal axis factoring, where you assume that it is on a constant and it is working on shared variance principle. And parallel analysis by default it takes, if you don't want, if you try to go with the eigenvalue. First I'll show, let me show you one by one. So this is, let's see it with a parallel analysis. And it is, if you see this based on principal component and based on factor. So if you go here, rotation. Now focus on rotation. Rotation is You can see there is an orthogonal and there is oblique, or this is the correlation matrix. So basically we use the correlation matrix to use this. Oblique, you can see there are many types of oblique. Generally we use either oblimin or promax. You can use both. And you use oblimin when you see that there is a correlation between the factors. So even if there is a 0.3 correlation between even in one of the factor, then you should go with oblimin. So PC means principal component and FA means factor analysis. Yes, I think you have written. Thank you. So now see this, till now I am only telling you. So if you see the chi-square, right now we will not comment on model fit and all. First see this factor loading. So here you can see that factor 5, 13, 6 and 3, they are getting loaded on factor 1. So how many factor structure you can see here? Yes, here we have used, yeah, you can use oblimin also. If you click this, it will be same.
3 factors.
3 factor solution. So 3 factor, now I will show you the individual interpretation of these things. So this is when I have kept the loading. If you see this, loading means I have kept it 0 now. Okay. So now what can you see? That all these 16 items, they are getting loaded on all the factors. Do you agree with me? What are these? These are lambda, which we discussed, factor loading. You remember that equation where I have written that item I1 is equal to lambda 1 F1. Oh, it has disappeared. Means, have you understood? I don't want to change the screen because otherwise time is already less. But can you recall what will be the equation? Item 11 will be lambda 1 F1 plus lambda 2 F2 plus lambda 3 F3 plus error. The equation of item 11. Have you understood? Should I use the whiteboard? Let me use the whiteboard. You are saying understood, so should I leave? Means, and then again for item 12 also, so there will be a separate equation for all these items. For item 12 also, it will be like lambda 1 factor 1. So factor 1 is affecting the item by this lambda. So this lambda is known as the loading or factor loading. So now I told you to calculate. So all of you please calculate the communality of item 11. All of you please do this. What will be the communality? How I explained the communality? Communality is lambda 1 square of factor 1 plus lambda 2 square of factor 2 plus lambda 3 square of factor 3. This is the communality, means shared variances. Yes? Shall I do it on calculator? So what will be the value? If you see 0.63 multiplied by 0.63. What will be the value? 0.39. Are you 0.39? And 3969 or 397. And what will be the next? It will be 0.003. 0.003 multiplied by 0.003. It will be 0.0. So we can call it as 0. And next is 0.07. So 0.07 multiplied by 0.07. So that is your 0.005. So 0.0049 plus
0.039 by 0.0.
plus 0.397. the value will be 0.60. Okay, 0.40. And what is uniqueness? 1 minus communality. So if you deduct 0.40 from 1, what will be the uniqueness? It will be 0.6. So this will be your uniqueness. Uniqueness means this much is the error. How do we interpret it? Like 60% of the variance in item 11 cannot be explained by factor 1, 2, and 3. Now, have you understood this statement? If you have understood, for one item, you can understand for rest of the item. Can someone say yes or no? You have written 0.40. So yes, communality is 100, 100 minus or 1 minus uniqueness. True. Communality is the shared variance. Uniqueness is the error. Lambda 1 F1 plus lambda 2 plus lambda 3 plus E. So shared variances are square addition of square of loading. And uniqueness is the error. So if in this uniqueness, where is the error which now you can see, like every factor is getting loaded on all the every item is getting loaded on all the item. But what the criteria? If there is a strong loading of one item on a particular factor, that particular factor we are going to accept. So that's why the rule is you should hide loading below 0.4. You can take up till 0.5 also. Many people say that you can take up till 0.5. It is up to you. So if I make it like 0.4, from here you can change. So you can see here there is a clear-cut structure. So factor 1 is having 10, 7, 14, 4, 12 and 11. Factor 2 is having 3, 6, 13 and 5. And factor 3 is item 9 and 8 and 9 item. Okay. So this is a 3-factor structure. And if you see the uniqueness, there are various items with their own error. So this is the factor structure. Now coming to the other part of the explanation. If you see this, this is the factor characteristics. So it is right now I have not clicked this thing. So you can click on the scree plot, parallel analysis result. I have not tested the assumptions. So that was the first thing which I should have done, because only based on that I can take a decision whether I should go ahead with this factor analysis or not. So if you see the assumptions, these are the KMO measure. So what is the KMO measure? If you see the overall KMO, it is acceptable, 0.737. Okay, so this assumption is satisfied. If you see the Bartlett's test of sphericity, that is also less than, so that is met. So my sample adequacy and KMO, the KMO and Bartlett's test, that means factors are correlated with each other. Two assumptions are met. This is the factor structure. And then if you come here, this is the scree plot and parallel, which we have shown in the slide. We have taken from here only. So you can see that this is showing a 3-factor structure. This has factor 1, this has factor 2, and this has factor 3. This one. And here you can see this is the unrotated solution. Means if you don't rotate, this is your unrotated. Unrotated solution, if you come to cumulative variance, so it is only explaining 4.1% of variance. And here, sorry, this one cumulative, that is the proportional. If you make it total, it is the 29% of the variance in this. These items can be explained by factor 2, 3, 1, 2, and 3. Now coming to rotated, if you see the rotated also, it is not like that much is showing the same thing, variance. So variance ideally, then that means it is not a very good structure. At least it should be able to explain 60% of variance. So you can report this and further you can test this in your. So this was the 29% variance. So scree plot you have seen, unrotated and rotated solution you have seen. Now you can see the factor correlation. Why you should see the factor correlation? Because that will tell you whether you should apply oblimin or not. So you can see there are many where factor 1 and 2 it is 0.3 and factor 2, yes, at least there is one. I said that if at least one correlation is more than 0.3, then you can go ahead with the oblimin. So here it is 0.3. So you have done a right thing to go ahead with this. Again, these are some, till now, I think this is the only important thing which you should see. So what you will propose? Now, if you want to go with eigenvalue more than 1, then you see how many factor structure, then it will give you the eigenvalue of the factors. So then it is proposing a 4 factor correlation. This is the scree plot. Again, it is showing 3 only. But if you see the eigenvalue, then it is showing you 4. Eigenvalue, it is giving you 4 factor structure. Because factor 4 is more than 1.14. But again, with this, you can see that the variance in the previous one, it was 29%. But with the 4 factor structure, it is giving you 34% variance. Okay. And if you come up, then you can see here the factor. But you will not accept this factor 4 and 3. Why? Can someone say? Why we will not accept factor 4 and 3 here? Why? Because in factor 3, if you see, there is only single item. In factor 4 also there is only single item. So this is one thing that if a factor is getting loaded only by one item, or if there is only one item, at least there should be minimum of 2 item loading on one factor, then only you will accept that factor. So although here the variance explained is more, but that 4 factor structure you are not going to accept. Why? Because here factor 3 and factor 4, they are getting loaded only by single item. And that generally we don't accept. So it should have at least minimum of 2. Otherwise we say 3. So that's why we will discard this. And this all you can write in your write-up. That you tried with the eigenvalue. Eigenvalue has shown it to be like these were the result of the eigenvalue. That's why you have rejected that. And then probably you can go for the other option if you wish, like manual and all. But with the parallel analysis, you will see that there is a 3-factor structure. And this you will use in the confirmatory factor analysis.
These 3 factors will be confirmed.
Yeah. Confirm means these you have proposed. Now you will confirm in the confirmatory factor analysis with rest of the sample 160. So I will show entering these model means there I will have first factor with all these items. So tomorrow what I will show, I will make 3 different factor and I'll move these items into that particular factor. And then you can see the structure and the other model fit measure, which we are not seeing today. We are not going to see the model because we are not proposing, we are only proposing the structure here. And those structure we will test on the next set of sample size, seeing the model fit measure.
So ma'am, here considering these factors, we will discard the last 4 items, 1, 2, 15 and 16.
Yes. We will not enter those items in our final thing. We will not take these. Because the error is very much, you can see 82%, 79, 85, and factor loading is very less. If I make it 0, if I make it 0.
इसी लोडिंग में करना अब आया कॉम्बिनेशन में ऐसा इसको क्लिक किया
Yeah, just a sec. मैं कभी-कभी टाइम लेता हूँ.
फिर से ट्राई कर हाँ
Sometimes it gets hang.
फिर आ रहा है
Yes, now it is coming.
ओके
We say minimum loading should be at least 0.5 on any factor, but you will say 0.3 as 0.45, 0.3 also you can say if it is a multiple item are getting loaded. But if you see this item number 9, it is not very 1. If you see, this is, it will come. See this only 0.2 and 0.2 item 1. Error is 82%. Means 82% of this item cannot be explained by this empathy. Here also error is 82%. Loading is very less, 0.3 and 0.2. Item 6 is at least getting loaded here on factor 2 strongly, 0.5. Strong loading is at least 0.5. So it is not getting strongly loaded. If you see this item 3, again it is there on factor point, like on second factor it is getting loaded. So if you see, if you make it 0.4, then these items this will not be loaded, like these will be not. So you have to delete, I mean, not delete means in the final proposed structure, you will not enter these items into the final structure, CFA. So item 1, item 2, 15 and 16. This you will not keep. And other item you will keep. So in factor 1, these many items, factor 2 and factor 3. So these are the 3 factors which we will do tomorrow. So till now, up till this point, so any other? So we have seen the factors extraction, method of factor extraction. We have seen the rotation. What is the value of? Now if you want to see the orthogonal, if you click this orthogonal instead of oblique, then you see what is the factor structure. So in that case, you can see here in the bottom it writes here no rotation method applied. No, here in orthogonal I have not selected. It's none. So varimax is the most important, which uses the maximum variance. So if you see the varimax, again you can see, it is again giving you a 3-factor solution. And if you see the variance, it is again explaining the same 29.6%. Rotated one also, if you see the rotation. This is again 29.6 only. This 29.6. So not much change, even if you change the way of rotation. And if you see the correlation in orthogonal, since we said that there will be no correlation, so you can see it will write 0. Can you see? Correlation between same factor is there, but with other factor it is 0, which is not the case usually, because if it is a factor of same underlying construct, we expect that there will be some amount of correlation. So that's why this Orthogonal generally we use for which type of scale? For formative. Because formative, remember we discussed that it's a multi-item measure. So there we use orthogonal because we don't expect our factors to be interrelated. So most common type of extra rotation method used in PCA is the orthogonal. But in EFA, it is the oblimin. Have you understood up till this point? If yes, I think we will start with the breakout room activity. No, tomorrow. I'm not saying today. Don't worry. So,
tomorrow, ma'am.
yeah, I know that.
अब वीडियो शेयर कर देंगे उसके लिए.
We'll share the video. You can see in 2x or like increasing the speed. And you especially this analysis part, and then we'll do it tomorrow in the breakout room. The first activity. Then I'll take CFA. Tomorrow the time will exceed definitely. Tomorrow is the last day, so I have to show many things. The PCA demonstration, the CFA, then you have to do the 2 breakout room. 1:30 से नहीं करना कल.
कर सकते हैं.
Can we join tomorrow at 1:30? I don't know about other people.
Yes, ठीक है, कर देंगे. Okay.
Okay. Other because generally it takes time and questions are also there. Okay. So tomorrow we'll start at 1:30. Okay.
Thank you, ma'am.
Thank you. Thank you, everyone. See you
Thank
tomorrow.
Yes.